Okay, so we've got a density calculation here. We have a model. We recognize that centimeters, oh, I wrote centimeters squared. Centimeters cubed and milliliters are units for volume. Those people that caught that, thanks for saying something. And thank you. And we got this model for how to solve a problem. Now, so far we've talked about writing down our givens, that's the G, write down our unknown, that's the U, and we write down our formula, which we've talked about previously, is the equation. Okay, so GUE, and we're working towards a guess model. Givens, unknowns, write the equation, and then we want to substitute and solve. That's this S portion right here. We're subbing the values in from our initial problem, and then we have our statement, the second S, for our full guess format. Now, if I'm giving this a full communication mark, I'm giving myself, really I only give 1 mark for the unknowns and the givens. I have my formula, I have my solution with the proper answer, and I have a therefore statement. I'm going to give myself a mark out of 4. Now, with that as the marking scheme, and with the answers written at the side, give yourself a mark out of 4. See how you do, okay? Again, I'm going to go through my marks. I'm giving myself a mark for writing down my givens and unknown, for writing my equation, for subbing in and solving, and for writing a therefore statement. Now notice I've used the 3 circles or the 3 dots for my therefore symbol. I haven't used the word therefore, but you should always have a statement to put your answer back in context, okay? People feel good? If you feel like you got 4 out of 4, fantastic. I want to try the next one. Again, I've got a model. The density of silver is 0.49 grams per centimeter cubed. Now, even if they didn't tell me it was the density, I can tell that if I have units where there's a mass unit as a rate over a volume unit, that's always going to be a density, okay? So grams per centimeter cubed of a sample of pure silver has a volume of 12.993 centimeters cubed. We want to know what the mass is. Again, I write down my unknown, I write down my given values, and I write the version of the density equation that isolates for the mass. Now, if you're somebody who's a memorizer and you're memorizing that D is equal to M over V pyramid, that's fine. Those of us that are more advanced in our math skills, we might say, well, I could start off with density is equal to mass divided by volume, but I know from math class that if I wanted to get M all by itself, wouldn't I multiply both sides by volume? You guys remember doing that stuff? It's cross multiplication. Whatever I do to the right-hand side, you guys repeat after me. I have to. Whatever I do to the right-hand side, I have to. Yeah. So multiply both sides by V. That means that the right-hand side is going to have the volumes canceled out. And I would end up writing mass is equal to volume times density. That's the way I think about this. Like if I'm isolating the mass, I do that little thought process. Honestly, I do it in my head. I don't memorize pyramids. And nobody beyond the grade 9 level, nobody that I know anybody, memorizes pyramids. Because frankly, pyramids, they're like training wheels. And the training wheels should come off. And so if you're somebody that just memorizes D is equal to M divided by V, and you do something like what we just did there every time in your head, that's probably working towards maturity, honestly, okay? For now, though, for grade 9, I'm going to allow you to use this. So if I see this float around every once in a while, that's fine. I'm not going to slap anybody on the wrist, but this is the way we should be working, okay? Because we want to be working towards math proficiency. Anyway, we got this mass is equal to density times volume. We sub in our values. We've got units of grams, in case that's not clear to you. And we end up calculating our final answer. I'm going to quietly do this question. Can you? Don't peek. Don't look while I do it. You guys do it. If you're a cheater, you're going to look. See if you can do it without peeking. Let's see if we get the same answer, okay? I won't narrate it. I'll just write. Oh no. We're about to run into a problem. 15 milliliters. You guys know that centimeters cubed and milliliters are not the same volume units, but did you know that centimeters cubed is the same size as a milliliter? So it turns out that it's okay to do this, but a lot of people that are purists would say, let's rewrite this as 1.12 grams divided by milliliters. Because 1.12 grams per milliliter times 15 milliliters, it turns out that if I have a milliliter in the numerator and the milliliter in the denominator, units can cancel. Look at that. A numerator milliliter and a denominator milliliter actually cancel each other out. Okay? So I'm just putting it out there that that's something that we could start to be aware of. All right, again, if you did your work independently, you probably didn't do this centimeter cubed to milliliter thing, and hopefully it all worked out for you. But I wanted to introduce this as an idea so that we have this as in the back of our minds, that these are equivalent units. It's just that centimeters cubed are often used for solids and milliliters are often used for liquids, okay? Well, always used for liquids. Down here, again, we got pure gold, 19.3 grams per centimeter cubed. Again, this lets me know that we've got a mass over a volume. So even if they didn't tell us that it was a density, the units told the story. How large would a piece of gold be if it has a mass of 318.97 grams? Now in this one, we're trying to find the volume. Again, if it was me and I have D is equal to M over V, I would, this is a two-stepper in my brain, multiply both sides by V. That cancels out the V's. And that leaves M is equal to V times D. But I'm trying to get V all by itself, so then I would have to divide both sides by V. And I end up getting M divided by V is equal to D. Oh, shoot, I divided by the wrong thing. Well, that's not helpful. I was trying to get V all by itself, wasn't I? So I've got V times D equals M, and I would have to divide both sides by D. And cancel out the D's on the left-hand side, and that would leave me with V is equal to M divided by D. Now, if you're a whatever you do to the right side, you have to do to the left side kind of thinker, that's your process. If you're a, I'm not quite confident yet, I'm going to use the pyramid kind of thinker, then if I was looking for the V value, I would cover up the V and see that V is equal to M divided by D. And so that's what we have here in our example. V is equal to M divided by D, and they've plugged in their values and they've gotten their answer. Now again, try not to peek. I'm going to quietly do this guy. Right, so as we're looking at this, there are really only three different ways I can cook the D is equal to M over V equation. Either I'm isolating for D, or I'm isolating for M, or I'm isolating for V. That's it. There's only three permutations. And so this problem set goes through all three permutations. What I really want to nail home is communication format. Make sure that you really are getting your 4 out of 4 for your givens and your unknowns, your equation, your problem-solving process, and your final context statement. Okay, make sure that it's all there. And really, if you know what you're doing, 4 out of 4 should be a pretty common thing for you. Okay.